Welcome to Module 5, Lesson 24. So, dipping back into the fractions, our goal is I can express whole numbers as fractions and recognize equivalence with unit differences. Basically what we're saying, we've kind of touched base on this already, but recognizing that just because the denominator, the number on the bottom is different, the number can still equal the same thing. So, example of that, saying that 1/2 is equal to 2/4, because if I were to draw a number line, 1/2 would be halfway, and 2/4 would be 1/4, 2/4, and they both be on that, that was about the straight line, both be on that line. So going off of that, but now we're talking about specifically with whole numbers. So long story short, we know that 1 equals 1. That's a pretty basic thing. We know 1 equals 1, right? But we also know 1 can equal other things. We've learned that 2/2 is equal to 1. We also learned that 3/3 is equal to 1, so on and so forth. We can continue on and say that 20ths is equal to 1, which means if all of these equal 1, they're all equal to each other. 2/2 is equal to 3/4. 3/4 is equal to 20/20ths. 20/20ths is equal to 2/2. Basically, if the top number is equal to the denominator, it equals 1, which means any combination like this will equal 1. So if I had 1,732 over 1,732, that equals 1, which means that is equal to everything else currently written on this board. Now, that being said, we can also have things equal to 2. The number 2. So, 2 is usually saying I have 2 wholes of something, 2 entire things. So, if I had halves here, if I had 1/2, 2/2, that would be 1. 3/2, 4/2 would be 2, which would be 4 pieces. And how many pieces do I need to make a whole? 1, 2, just 2. So we know that 2 is equal to 2/4, which goes off the idea is that if the top number is double the bottom number, the numerator is double the denominator, the answer is 2. It means 2. So I could say that 6/3 is also equal to 2, which means 6/3 is equal to 4/2. Once again, I could just go crazy here and say 80/40ths is also equal to, which means 6/3 is equal to 80/40ths and is equal to 4/2, which is also equal to, oh, I already did 6/3, silly me, 8/4, which is also equal to 10/5. Top number doubling the bottom number, it's 2. So all those are equal to each other. Now you can continue taking this a step further and say thirds, or 3. 3, starting off with halves, would be 6/2, because you are traveling off this entire line. Make it a little longer. 0, 1, 2, 3, and each mark being for the halves. 1/2, 2/2, 3/2, 4/2, 5/2, 6/2. So 6/2 would be 3. Now, there's another way of looking at this. And remember, this is equal to a division problem. This does technically say 6 divided by 2 equals something. Well, if I have 6 split into groups of 2, how many are in each group? Or how many groups do I have? Or you can say, what times 2 is 6? 3. So there's multiple ways of looking at this. And doing this, I can also tell you that 9/3 is equal to that, because 3 goes into 9 3 times. 2 goes into 6 3 times. I could say 15/5 is equal to 3, because 5 goes into 15 3 times. So there's a pattern here. So this is what it's talking about when I'm asking and telling you about whole numbers as fractions, because these are all whole numbers, just they look funny, and how they can be equal to each other even though they look different. That's kind of like the majority of this problem, and as you go forward, you kind of get some more practice in this. I do want to show one last thing before moving on, and just show that this equivalence goes down to the fractional point as well. So let's say I had one whole, and I'm in halves. So I know one whole is equal to 2 over 2. If I was talking in halves, I would split this up like this and say I have 1/2 here and 1/2 there. I feel like we can comfortably say that 2 halves equals 1 whole. Now, the question here is, what can I break my halves into? Oop, that's a tiny, tiny circle. Let me make that a little bit bigger. Right? Let me show you. Starting on this number line, we're going to do a kind of tiny one here, but you should still be able to see it decently. Half right here, 0 and 1, so 1, 2 would be that. Now, if I'm going to do 2 for each one of these, that means I'm cutting each one in half again. So cut each one in half. Now that's 1, 2, 3, 4. So now there's a total of 4 pieces. Or I can say, how many pieces does it take to make a half? 2 1/4 pieces make 1/2. So now, with that in mind, keeping this in mind, one whole can be split into 2 halves, and each half can be split into 4ths. Now I'm going to erase this and basically just rearrange everything here. I have 1/2 and 1/2 right here. So I have 2 1/2s in this little cubby. Both of those together equals 2 halves, right? If I split that into 4 equal pieces, what would that be? Once again, I've started with that half, and now I'm cutting each one into 2 more additional pieces. Each one becomes 1/4. So once again, this isn't necessarily anything new. We're just looking at something at a different way, again, which is quite often what we do a lot. We don't really talk about new methods of math. It's more of how are we looking at something. We're still doing multiplication, division, addition, subtraction. We're still using tape diagrams. We're still doing number lines. We're still using all the strategies we've used before. It's just now we're looking at it in a different way. So hopefully this makes sense. Hopefully this was not too confusing. Zern and your other problem sets will help with this as well, but you can rewatch this video as many times as you like if that would help you. And I hope you guys all have a great rest of your day.